This is a presentation by Stephen Ellsbury and Austin Tanner about our bicycle turn signal, turn bike. In places where bicycle riders are everywhere, this situation is not an uncommon sight. It is incredibly difficult to see bike riders at night. Not only does this create an awkward and dangerous situation for bikers of possibly being hit by cars, but it also creates a stressful environment for nighttime car drivers. In order to address this problem, we have designed a turn bike, an innovative product that incorporates Arduino technology and a variety of LEDs to increase the visibility of bikers at night and to allow them to signal their intentions to other traffic, whether that's following traffic or oncoming traffic. In order to address this problem, we have designed Turn Bike, an innovative product that incorporates Arduino technology and a variety of LEDs to increase the visibility of bikers at night and to allow them to signal their intentions to other traffic, whether that's following traffic or oncoming. The front-facing set of lights have two blinkers, a right and a left, and the back-facing set of lights have blinkers as well as running light / brake light. The running light will run constantly, with the brake light application activating through a pressure switch on the bike's brake handles. The blinkers will be actuated by switches on the handlebars. Having a product that aligns with many of the core values of human behavior is extremely important for that product to succeed. And our product does just that. It appeals to our desire to acquire by being a cool piece of technology that gives bikers both freedom and power. Having easy-to-see turn signals and brake lights gives a biker more freedom on the road and power to do what he or she wants. This product also connects with the drive to bond by giving bicycle riders something to brag about to their bike-loving buddies. Bicycle fanatics love talking to other bike nerds about the new, cool thing they put or want to put on their bike. There is no doubt that this would help bikers bond. It also connects extremely well with the drive for safety. I mean, really. This was the main drive behind the creation of this product, to give riders added security in their nighttime adventures. This product finds a fantastic connection also with the drive to experience. With this product, bicycle riders will be able to enjoy peaceful nighttime rides without the fear of being run over. Bicycles and lights have been around for a long time, so other people have created products to address this problem. However, the Turn Bike has a competitive advantage over most of these other products for a couple of reasons. The first reason is that whereas the Turn Bike has both front-facing and back-facing turn signals, the majority of these competing products, like bicycle bike turn signal brake light horn, pictured on the left, and the acclaimed turn signal directional brake light horn, pictured on the right, don't have turn signal indicators facing forward to signal intentions to oncoming traffic. Those that do have front-facing turn indicators, like the bi-signal indicator bicycle light pictured here, are fairly spendy, with bi-signals having a price tag of over $70 on Amazon.com. The second reason is that most of these other models lack the visibility that Turn Bike has from its multiple lights and high placement on the rider, assuming most riders will mount it on their backpacks or jackets.
It has three sets of LEDs. The green LEDs are on push buttons to model the turn signals, and the red LEDs are on a pressure sensor to model the brake lights. The system works with the Arduino taking inputs from the sensors, computing, and then supplying outputs via LEDs. When you squeeze the pressure sensor, the Arduino records the change in voltage of that circuit and then changes the red LEDs accordingly. When you press one of the push buttons, the Arduino will blink the green rows of LEDs. This schematic diagram shows the circuits built around the Arduino board. The first turn signal has an LED from pin 13 to ground with a 560 ohm resistor. It has a push button from the 5 volt pin to pin 4 and a 10 kilo ohm resistor from pin 4 to ground. The second turn signal is identical to the first, but it uses pins 11 and 2 instead of 13 and 4. The brake light has an LED from pin 9 to ground with a 300 ohm resistor. It has a pressure sensor from the 5 volt pin to analog pin 2 and then to ground with a 10 kilo ohm resistor on the way to ground. Our prototyping process involves all three of the major techniques. We started by breaking it down, trying to do each system separately, the turn signals and the brake lights. Then we tried simpler problems. For the turn signals, we started by blinking an LED, then multiple LEDs. Then we put an LED on the push button, multiple LEDs on the push button. Then we did two buttons with two sets of LEDs. Finally, we made each set of LEDs blink. For the brake lights, we made LEDs change on a pressure sensor and then spent time fine-tuning it. We had to do multiple iterations to make some parts of the system work. We tried to make LEDs the same brightness by changing resistance, We also changed which systems were which colors. We changed programming for the pressure sensor to make it more or less sensitive and to be more effective. It didn't take a lot of original programming. We took programs for individual pieces, push button, blinking, and pressure sensor that we found online, and then added them all to one sketch that compiled the whole system. There were three major technical challenges. The first was getting all of the different sketches written by different programmers to coexist as one. We had to change the names of the sensors and of all the variables so that they could coincide better. The second challenge was getting the lights to blink when the button was pressed, instead of just staying on. We had to add the blinking commands into the loop section of the sketch after the push button command. The third challenge was getting the lights to be the same brightness. Red and green LEDs are very different. We had to adjust the resistors, and eventually it just changed the system so that the green LEDs were on both turn signals and the red LEDs were on the brake lights.
The things we did well in this project was that we didn't reinvent the wheel. We used already written sketches and combined them to write our own. We also connected with 4 out of the 5 drivers of human behavior. And lastly, we prototyped and broke down our problem so that it was easier to tackle.
Nevertheless, there were things we could improve on. We could have done more Arduino programming ourselves so that we would learn more. We could also have done more knowledge construction beforehand so that we would come into this situation knowing more about our limitations and capabilities, then that way we could make a better product. We could also have spent more time brainstorming to come up with a more creative idea, as there were lots of other people building bike makers.
We learned some very neat things from this project as well. First, Arduinos are incredibly powerful and can be used in a lot of applications. We also learned that our first ideas are not always our best ideas, and we shouldn't pick something just because it's the easiest. And it's also good to have criteria to look for in a final product, so that we can narrow it down and know exactly what we're working towards.